Ladies and gents, boys and girls, welcome to today's webcast of Daphnis on the Acrobat Mission. My name is Quasi, the CTO of Saturn Aerospace, and I am joined here today by our CEO, Caden.
Yes, hello everyone, how are you guys doing today? Glad to have Daphnis back on the pad once again.
So today we have an important mission for the Acrobat, and essentially this payload is only about 1.5 tons, but it's going to an orbit of 300 kilometers by 250 kilometers. Now this is pretty similar to the size and orbit of our SCOM satellites that we have, but we launch many more SCOM satellites each launch. Now, of course, we have a lot to talk about, and obviously we're looking into some new ideas for Daphnis coming late this year, hopefully. But Caden, is there anything you can tell us currently about those ideas?
Basically, so Daphnis was originally designed to replace Phoebe and be Saturn Aerospace's new workhorse. It's finally starting to prove itself to be that. So since that's starting to happen, we on the Daphnis team are starting to look ahead into the future, seeing what we can improve, what we can make more simplified, all that kind of stuff. There's some stuff we're looking at, like maybe going down to 4 landing legs to be more mass optimized, switching to 9 engines on the first stage, and I think probably the change I'm most excited for is a reusable second stage, which is going to drive down the cost of each Daphnis launch by a metric a lot.
Your ship is in final recovery position.
Yeah, so basically the only main mean of cost is actually the fuel and the working cost, the labor.
Yeah.
And as they say, a better part is no part, of course. If you don't need the part and you know it's useless and you could do it without that part, then launch it, you know. Of course, if we turn around that booster, it takes a couple of days, but if we are able to land stage 2 as well, then the turnaround will be a little bit longer initially, but of course we have many more stage 2s than stage 1s because right now it's not reusable, so it would be an insane turnaround time. And we could launch hours after the first.
And the reason we have a lot more boosters than second stages, and that'll be the case for when we use them, is the second stages will probably have to stay on orbit for a while just to wait their opportunity to come back, and then also they have to get refurbished, get the payload installed when they get back to the ground. But the boosters, we are looking to get that really optimized, so they land, bring back to the launch complex, made with the second stage, and put back out on the pad.
Exactly.
We're looking for minimal refurbishment.
That's it. And today, of course, this is the No Time for Caution booster. This is its 4th total flight. Again,
booster of fantastic is on the way.
Leading the pack on launches. Currently, it is the most flown booster on Daphnis so far, and it's doing very well. It's shown
on site and no time area for launch.
It's shown that it can launch rapidly and reuse quickly.
You know, No Time for Caution. It's a special booster. We on the Daphnis team, we love this one. It's the first booster to be reused. Obviously, its first flight was the second mission of Daphnis, the first booster we used. We couldn't reuse it for issues we had. It was going to cost way too much to get it ready for fight again because of some damage that happened. So this booster that's out on the pad is like a special one. So hopefully it doesn't blow up.
I hope so too. And if it does blow up, we are of course safe. We give the customer their satisfaction of rebooting
Weather
their
balloon
launch
is clear from restricted airspace.
and paying for their satellite. So anything that goes wrong today, if that did happen, then of course we could obviously fix that and implement it.
The booster's main goal is to get the second stage to igniting and getting payload orbit. If it fails after that, it honestly really doesn't matter. We've got more boosters in production. We can always replace a booster.
Exactly. The boosters are basically just dead weight if we don't need them. We tried to land them so that we can reduce costs. We have enough money to not do that, but we're not going to risk that. And of course, we want to try and land as much as possible because it helps us to make a sustainable future for the Earth. And when we go to the Moon and Mars, a sustainable future for there too. We don't want to ruin that. So it'll be great to keep as much as we can. Now we are 3 minutes away. In a minute we'll hear the go no go poll. Now, Caden, of course you've been a mission controller before. Tell us a bit about that mission control LD poll.
The final go no go poll is like the most important call out before launch. This is like the final time where the LD checks everyone is go. When you're launching a rocket,
Hold. Range.
Go.
Daphnis control.
Daphnis control is go.
Recovery.
Recovery is go.
Propellant.
Propellants go.
Engines.
Engines go.
This is LD confirming go for Acrobat Mission.
great news there. We are go for launch. Anyway, back to what I was saying. When you're launching a rocket, a million things have to go right, and if any one little thing goes wrong, that might screw up for us for the entire day. So that final LD call is really important. Just make sure all systems are green ahead of launch.
Propellant load complete.
100%. And a bit before the launch now, 2 minutes, I'm going to talk a little bit about the payload. So today we have the Acrobat, of course, in our pairing, and it's going to
Final
study
spaceport
the
alarm sounded.
magnetic fields of the Earth and the Moon. It will collect measurements of magnetic strength, direction, and variation as it travels through space. So, in simple terms, the satellite acts like a highly sensitive space compass, mapping invisible magnetic forces around the Earth and the Moon. Small LOS there, probably due to SCOM uplink. We have a mix of SCOM V5 and V6 in orbit, so it might have been switching over. The infrastructure on V6 is much greater, and that's our current version. We launch around about 15 per mission, or we try to, on Rhea anyway. On Daphnis it's a little less because we have less payload capacity and a smaller fairing.
Yes, with 56 seconds left on the clock, me and Quasi are going to be quiet now and let the rocket and the MCC operators take you through the final seconds of launch.
Hold.
Seems we've entered a hold here, not 100% sure why. Let's have a look.
While we wait to hear official word, with my trained eye, obviously I know this vehicle at the back of my hand.
Range to launch director.
Go ahead, range.
It's looking like the strong back did not retract.
We're
gonna retry that.
The retract on that strong back.
Copy, we're gonna retry.
This is Daphnis control to LD.
Go ahead, deafness control.
We are still awaiting confirmation on the launch infrastructure site, so we will wait for safe confirmation of strongback retraction and fixing.
Yeah, it appears that strongback has retracted now. We're just gonna redo the go no go poll to check all systems go. So this is LD for the go no go poll range.
Go.
Deafness control.
Deafness control, let's go.
Recovery.
Recoveries go.
Propellant.
Propellants is go.
Engines.
Engines is go.
LG is go to resume count. My mark. 3, 2, 1, mark.
Strong back retracted.
Hold.
Looks like I had an issue with the clock there.
Recycle count to 60 seconds. On my mark. 3, 2, 1, resume.
Right, we're now 58 seconds out once again. Just running through some final small issues there. That's to be expected with a launch vehicle. We do
LD
have
is
the
go for
strong
5.
Got a call out there. Well, we are going to be quiet once again.
Vehicle handoff is complete.
T minus 10, 9, 8, 7, 6, 5, 4, 3, ignition, 2, 1, lift off. Oh, never mind. Lift off.
And there we have Daphnis taking the skies once again. Temperature screens are showing 7 out of 7 engines on the first stage with a heads up belt.
Negative chamber pressure is normal.
So far so good. We're half a kilometre in the air. And apologies, this is the limitation of KSP, but it is a little laggy on the physics side. That should fix after we pass around 5 kilometres, so apologies for that, just for now.
You can see the gimbals on the 7 engines working overtime there. These are vital for keeping the vehicle stable as it heads to spin. Max Q.
I'm not 100% sure why, but that I think the gimbals might be counteracting the fins currently. I'm not sure, but we seem like we've got some oscillations.
This is a off-nominal situation. The vehicle might be able to continue flying.
I think it can. This is sort of a situation that we've done in simulations, and we've obviously tested, but we're going to see if we can come back from this. I'm hoping we can. So let's just.
If I remember correctly, when we were getting ready to launch Daphnis, we did go through basically every launch failure we could have. This is one of the things we had when the things got stuck in a position on the vehicle go, and believe every simulation we did, the vehicle was still able to reach its depending orbit, and the boost was still able to land. But obviously simulations are very difficult to find like environment, so we'll just have to wait and see what happens, I guess.
If you heard that, but we're continuing through a normal trajectory minus the roll. So the roll, oh, it looks like it's slowing down. Oh, maybe not. I might have said a bit too soon. Oh, it seems like it's trying.
On a more positive note, this tracking view is absolutely beautiful right now. You can see Daphnis leaving a condensation trail, leaving its mark in the sky as it delivers another customer payload to orbit.
Now, apologies if you do get dizzy quite easily, but there you go. You can see the contrail of the vehicle. Those will essentially now turn into clouds, so not unfriendly for the environment at all, really. Liquid hydrogen and oxygen is basically water, or H2O.
I guess you could say Daphnis is the most over-engineered cloud maker in the world.
Good news, we eliminated that problem, and we are now pretty much rollers.
Nice view of Florida as we ascend from the Space Coast.
Yeah, you can see Tampa over there on the west coast, and currently Florida. Sorry, Orlando's in view, the Space Center's in view now, so we're about to hit separation here.
I believe you could also see the Gulf of Mexico there, if I'm not mistaken.
Mr. FTS is saved.
So they have me go.
Stage separation.
SCS-1.
And there we go. Daphnis booster number 4. No time for caution. It's heading down for the drone ship once again.
Apologies. I meant to say during the countdown, we are actually doing return to launch site today. This payload is extremely light.
My mistake.
No, it's all good. It's a light payload and it's a very, very low orbit for what Daphnis does, so it's actually pretty good. But
all stations, this is recovery for boosted landing go/no-go pole. Range.
Go.
Daphnis control.
Daphnis control is no-go.
Alright, what is the reason for the no-go? Daphnis control.
We hit some issues with the hydraulic pressure on the Daphnis control system.
It did sound like we are no-go, but when we have a no-go poll, the team just skim through the data like 1 or 2 more times, just make sure that's definitely the best call out. So we'll wait to see if they have a definite verdict for the day.
Yeah, and if we are no-go right now, we still have the entirety of the landing. So about 20 seconds before the landing burn, we're still good to abort if we had to. So we'll see how that plays
This is Daphnis control to recovery.
Recovery, go ahead.
We had some recovery in the pressure in the hydraulic system, so preempt to go until further notice.
Okay, it seems like we might be go for landing. That's good news.
Alright, all stations, this is recovery for go/no-go pole again. Range.
Go.
Daphnis control.
Daphnis control can eventually go until further notice.
Propellant and engines.
Propellant engines are go.
Launch director.
LT is go.
This is recovery. We are go for booster landing.
Perfect. We go, ladies and gents. Now, on the right, you can see the stage 2 pushing onto space. You might be able to see Florida. But on the left, more importantly, which will come up as a big screen now, we have the basically the landing for this webcast. So let's have a look here and see what happens.
Yes. Obligatory shout out to the Daphnis guidance and navigation team. You might have just seen that, but the booster did pick up a little oscillation, but it was able to stabilize perfectly. You know, Saturn Aerospace has the best engineer in the world working on our rockets, and it's just so amazing to see what they can pull off.
Daphnis hydraulic pressure is nominal.
And good news, that issue that was there is no longer a thing, so we're going to see this landing burn any second. There we go.
Landing burn startup.
Right, looks like we do have 3 out of 3 engines. We'll transition down to 1. Might have already happened.
I believe it might have.
Landing legs deployed.
Yes. The gear are now coming out.
Oh, it does seem like we're on 3. That's my apologies. The booster might have determined that itself. I'm not sure, but there we go.
Deafness has landed. Recovery operations move in with section 2.1 and deploy the Ninky Nonk.
And there we go. The Ninky Nonk on its way from the safe, secure location, and now going
Yes.
to recover. So it
You know-
does seem like we've lost data. I apologise.
The Ninky Nonks, when we do RTS missions, do get a nice little hut. We should look into implementing that for the drone ship ones.
And there we go, Seeker. What an incredible recovery of that oscillation on the booster. We've managed to land
Yes.
that booster after that. And we've also managed to get the payload into space. And it's in the right orbit. So, ladies and gentlemen, I think that is a win from us. We are, of course, going to look into that issue. But, Caden, I'll let you take away.
Yes, just booster 4, no time for caution, proving why it's a fleet leader once again. We've got another second stage in orbit with a payload. It's been a really good day today. A lot of happy people over here in mission control. And I think with that, we will be wrapping up today's webcast. So to check out our launch schedule, go to saturnaero.space is the URL, I think, I believe.
Yeah, that's it.
Yes, and then you can see our launch schedule. And I think, well, that's going to be it for today. So enjoy the rest of you guys' days, and we will see you guys later.
Goodbye.